Hello guys, welcome once more to class online, and my name is Mr. Jamb. Now in this video we shall be looking at Jamb Physics 2019, and we shall be looking at question number 1 to number 5. Now are you ready? Now don't forget that if you really enjoy this video, please like the video so that you can get more content from us from time to time that will help you, and also tell your friends about us. We have much to share with you and to help you with. Let's go to number 1 right now. It says the force required to make an object of mass m traveling with a velocity v turn in a circle. You can see the word circle stands out, or for just r is what. Now whenever you see the word force and circle, there's one particular substance that makes things move in circle, and that's centrifugal force. So now this question is simply asking for the formula of centrifugal force. Whenever something is going in circle, there's only one force in circular motion, because this topic is under circular motion. And the thing that makes your fan roll, that's anything in circle, that's like your fan. If you have a fan in your house and power goes off, now your fan keep moving. What force is moving your fan when there's no power? That is called centrifugal force. Now, but this question is simply saying, what is the formula for that force? Okay, that's what is the centrifugal formula. So let's check it out. Now, centrifugal force is the force that moves an object in circular path, right? E.g., a fan. Now, centrifugal force is given by the formula mv squared over r. I always say mv squared. To me, mv sound like momentum, because the formula for momentum is mv. So I say centrifugal force is mv squared over r, which is like saying momentum squared over r. Okay, so the formula for momentum and for centrifugal force is mv squared over r, and that is our answer, mv squared over r, making option B the correct answer. But the formula can also be modified. Okay, you must know that v in circular motion, that's a velocity in circular motion, where m is my mass, v is my velocity, r is my radius. So v is also given as wr, where w is angular velocity and r is my radius. So if you solve that further, w square r square cross through the r, you'll be getting m times w square over r. So the formula for centrifugal force can be mv square over r, but don't forget it can also be modified into mw square over r, where my w is my angular velocity. Is that clear? So that's my answer, and that's all for centrifugal force, the force that moves things in circular path. Good. Now let's take out number 2 now. Number 2 says an ice cube flows in a glass of water filled to the brim. What happens when the ice melts? Now when you have ice in water, what do you think will happen if you have an ice cube? If you have a cup of water filled up to the brim and then you have ice in it, now the water is filled up to the brim, that means there's no space in the cup again. Now, and then there's no water around. The cup is full and the ice is in the water. Now the ice is in ice form. That's the ice is solid. Now when it melts, will the water overflow, or will the water remain full, or the water get lower? That is, what is the effect when the ice in water melts? Will it increase the water quantity, or get it lower, or remain the same? Okay, do you have any idea? So let's check out the options first. There's a drop in the level of water. Is that true? In the water in the glass due to condensation on its outside. B, the water level remains the same. C, the water in the glass overflow. D, the level of water drops because melted ice occupies less volume. How true is that? Actually, let's check it out now. Now, this is a cup of water, and this is my ice, and this is my what happened at the present is ice is present in the first one. When ice melts, can you see that the quantity of water remains the same? That and it is the same volume. That means the water level will not increase. That means it won't overflow. Okay, what I mean, and why won't it overflow? When the ice become water, it adds to the level of water, right? But you may be saying yes, it will make the water to become higher, but that's not true. You are very wrong. What is true is that the ice you see in that picture is occupying a space. So when it melts, it becomes water, and the water occupies the same space that the ice is staying. So the level of water does not increase. The ice only changes to water, and the water occupies the space of the ice. So the water level remains the same. So the water in the ice picture have its own space, and the ice have its own space. The ice changed to water, and that new water occupies the space of the ice. It remains the same. There is no extra quantity. So the answer to number 2 is the water level remains the same. Do you get the scope? That's the way it's worked. That's the way it's been explained. Okay, so let's go to number 3 now. A 500-kilogram car, which was initially at rest, traveled with an acceleration of 5 meters per second square. Is kinetic energy after 4 seconds was what? Now, this question is asking for kinetic energy, right? Now, you know that the formula for kinetic energy, that's the most important thing here, is 1 over 2 mv squared. You know, I always say mv is momentum, so I would have said 1 over 2 momentum squared, but the v is not for the two of them, it's for only, and sorry, the square is only for v, it's not for momentum, it's just for v. So 1 over 2 mv squared, that's the formula for kinetic energy. And please don't forget, it's very key. Formulas are very key in physics, okay, because formulas are keys to open doors of question. If you don't know the formula, then you can't answer the question. Let's go. 1 over 2 mv squared, 1 over 2 m. Now, in the question, I was not given v. If you notice, there is no v. I was only giving mass 500, that's m. Then I was giving acceleration and I was giving time in 4 seconds. But you must know that acceleration is v over time. That's the one I wrote in red. Acceleration is v over time. Okay, so v is therefore acceleration times time. So if you just multiply, you get your v as acceleration times time. That means the question is trying to scope you. That means you must be smart to know that whenever you have been giving acceleration, you have been giving your v. Okay, v or velocity is just acceleration times time, and that is just it. So I will substitute that in now. So therefore, I have 1 over 2 m. My v is now a times t. That is the formula for v squared. Okay. Now bring in the square. That will become 1 over 2 m times a squared times time squared. Okay, giving me 1 over 2. My m in the equation is 500 times my acceleration is 5 squared times 4. That's my time squared. So giving me 1 over 2 times 500 times 25 times 16. You multiply that and you divide that by 2, you're getting 100,000 as your answer, which is 10 to the power 5 joule. And that is the end of that question. 10 to the power 5 joule. Now, there's nothing special about it. Just know the formula for kinetic energy as 1 over 2 mv squared, and then you go to go. Now, don't forget that v can also become 80. Okay, like in this question. So let's go on now to number 4. Which of the following are true of atoms? Which of the following are true of atoms? Okay, atoms are indestructible. That means they can't be destroyed. Is that true? Then the number of protons equals the number of electrons. Is that also true? The atoms of different substances have different weights and all of the above. Atom, from the law of conservation of energy, atoms are, it says energy cannot be created nor destroyed. That means atom cannot be destroyed, and making A true, atom can't be destroyed, but they can be changed from one form to another. But to say that they are indestructible, you are right. They can't be destroyed. 2, the number of protons equals the number of electrons, and that is also true. Proton number and electron numbers are the same. Now, this is where I explain that here now. This is, now look at the drawing. We have proton number below as 92. I use a sample of an atom. The atomic number for the proton number below is 92. Right now, look below. We have electron number below. It is the same thing. Electron number is always the same on a neutral atom for proton and neutron. And electron. So proton and electron always have the same number. Don't forget this. Whatever elements you are giving, the proton and the electron will always have the same number. Okay, but for neutron, you have to minus the mass number from the proton number to get the neutron. So for the neutron number, I said 238 minus 92, that gives me 146 as my neutron. So don't forget, what is different is the neutron number, but the proton number and the electron number for a neutral atom is always the same. Don't forget that. So making option B also correct. Now option C, atom of different substance have different weight, and that is true. Like the atom of oxygen has different weight from the atom of sodium. They are different, and therefore they have different mass. So the correct answer is all of the above. All of them are correct. Answer number 4. Now number 5, a pressure cooker saves time and fuel in cooking because inside the cooker the dash. Now how does a pressure cooker work? Do you have a pressure cooker at home? Now pressure cooker work by pressure, you know. And in pressure cooker, that's how the name comes. The water or whatever you are cooking is being done. Let me use a picture now. This is the science of pressure cooking. Now you have this now. Now it says pressure cooking is the process of cooking food under high pressure steam. Now you can't cook without water in a pressure cooker. That means you can't cook some food that doesn't have water content, that's high water content. Now employing water, it uses water or a water-based cooking liquid in a sealed vessel. Now this cooker is extremely sealed. That means the steam can't escape, and it cooks food by the steam. So that means because steam is hotter and stronger than water, so the food is the heat is coming from the pressurized steam. That means what I'm saying is that when the when steam is being created in this vessel, the steam is trapped inside, and the steam helps to cook the food to a very high temperature. Now, some of the food that we cook at home, they don't really boil well, but a pressure cooker is an excellent device that helps to boil food to an extremely high temperature, and that is good for killing any germs in food. So we have in a sealed vessel known as a pressure cooker. This is a pressure cooker, okay? So we have high pressure, limits boiling, and permits cooking temperature above 100 degrees Celsius to be read. Now, as in this vessel or a pressure cooker, the temperature can rise beyond, water boils at 100. Now, normally, our cooking stops at 100 degrees Celsius, but with a pressure cooker, it goes beyond. So it can help to boil the food beyond 100 degrees Celsius by the use of steam. Steam temperature is higher than water. Like our normal pot, we just let the steam go. So, like if you are cooking, you close the pot, but the steam escape. Okay, but in a pressure cooker, the steam stays. So that which is escaping, that steam leaving in your normal pot, makes the temperature to become lower than that of a pressure cooker. Because if the steam can't escape, it will be extremely high. It will be extremely under pressure, and that's called pressure. The pressure gets higher with the more you trap the steam, the higher the pressure gets, and that's why it's called pressure cooker, because it cooks with steam. With steam. Okay, so the answer to that question is therefore boiling point of water is raised. Okay, so that's why a pressure cooker is special. The pressure cooker saves time, and for them it's faster because the water boils beyond. So the reason why it is faster is because the boiling point is raised beyond 100 degrees Celsius, and that's why it does not take time. You cook fast and the food gets done quickly than normal pot, or your microwave and your other gas and so on. So the pressure cooker is faster because it cooks at higher temperature than therefore. So that brings us to the end of this video. Don't forget to like this video so that you can get more from us from time to time. That's if you really enjoy the video. We'd like to reach out to you from time to time and to help you to explain things that will help you in your journey of understanding physics. Until we see next time, guys, take care of yourself.